Hello everyone. Today's seminar lesson, we're going to learn how to find the limit of function using the graph. Okay, so given the piecewise function here, I have y equal x squared if x is greater or equal to 0. So this mean right here, I have the domain is from 0 to infinity, right? So zeros is included. The second one is x minus 1 if x is less than 0. So this one is the domain is from negative infinity to 0. Notice that 0 is not included. Okay. All right. Okay. So the first question we have is find f of 0. So all you have to do is plug in 0 for the function, right? But since 0 here is included in the first function, the quadratic function, so if I plug in 0 for x, 0 squared is 0. So therefore, f of 0 is 0. Right? Again, the reason I choose the quadratic function because zeros is included. Okay. So all you have to do is just plug in 0 for x. Okay, part B is finding the limit as x approaches 0 from the left of f of x. So 0 from the left, where is 0 from the left? So here, if I approach it 0 from the left, I get closer and closer to 0. Notice that I only get closer and close to 0, but not quite 0. Right, so what is close to 0? I mean, I get close to 0, a negative 0, here negative 0.1, or even closer, negative 0.01, or even closer, negative 0.001, or even closer, negative 0.0001. So you got the jig, right? So you get very, very close to 0 from the left, but never quite 0, right? So when I get close to 0 from the left, what is the limit approach to? So there, if I got very, very close 0 from the left, I see my limit approaches to negative 1, right? Negative 1. So limit as x approaches 0 from the left of f of x is equal to negative 1. Maybe I'll keep it to, I'll leave it as, I'll write my answers in red. Negative 1. Here's 0. Okay, now part C is I want to find the limit as x approaches 0 from the right of the function. So 0 from the right, let me do in green here. So I approach 0 from the right, so I get closer and closer to 0. So what happened when I get closer and closer to 0? What do I see? I see my function get closer and closer to 0, right? So 0 also. So here is f as my limit x approaches 0 from the right. The function, the limit is equal to 0. Okay, so part D is the limit at x approaches 0 of f of x. So this part right here, when they ask you the limit of a number approaches something, it means it approaches to the left and it approaches to the right. So as you can see, I have that as a limit as x approaches 0 from the left is equal to negative 1 as part B above, right? And limit as x approaches 0 from the right is equal to 0. So the limit from the left and limit from the right is not equal. It's not equal. So these right here, it's not equal. Since the limit from the left and the right is not equal, we say that the limit as x approaches 0 of f of x does not exist. Maybe I'll write it. So this implies limit as x approaches 0 of f of x does not exist. D and E. Okay. All right. In order it has to be exist, the limit 0 from the left it has to be equal to the limit as x approaches 0 from the right. Okay. Okay. Part E is f continuous at 0. So before we do this problem, you need to know what continuous mean, right? So a function is continuous. Let me remind you, a function is continuous if there are two things. If f, so for example, function f is defined. It has to be it has to be defined at 0, in this case at 0, but I'm going to say in general sense, okay, at a, and a is a point. A is a point. Okay, f has to be defined at a point, and in this point right here is 0, right? And the second thing is that second bullet point is that the limit as x approaches a, or x approaches 0 in this problem, of f of x, it had to be equal to f of a. Okay, so that's two things that define what is the continuity is about. Okay, so this problem, they ask you if f is continuous at 0. So a point here is 0. So let's see, what's f of 0? We know that f of 0 equals 0, right? We know that f of 0 equals 0. Now, all we have to prove that limit as x approaches 0 of f of x, it had to be equal to 0 also. Is it? Well, we showed that above in part D, the limit as x approaches 0 of f of x does not exist, right? Does not exist. So this is not true. This is not true, right? This is not true. So let me rewrite this one. So this one does not exist. Therefore, we have a first bullet point, but we don't have a second bullet point, right? So therefore, no. The f is not continuous at 0. Okay, the answer is no. And that's the explanation. Okay. Okay, so part F, is f continuous in interval from -1 to 1? From -1 to 1. What do you think? What do you think? Pause for a little bit and think this through, okay, before you answer this question. It's more like a critical thinking kind of question. From -1 to 1, notice that from -1 to 1, it contains 0, right? It contains 0. So this, this, let me highlight in yellow here. So this interval right here contains 0. And again, if f is continuous interval from -1 to 1, it had to be continuous everywhere in that interval, right? But here is in part E, we show that it is not continuous at 0, and 0 is between -1 and 1. So no, right? So no. So no. Because the explanation here, because f is not continuous at 0, right? So in between between that interval, there's a point that's kind of ruin this whole thing, right? So therefore, f is not continuous as from -1 to 1. Okay, so that's how we find the limit using graph. Okay. Thank you for watching.